Cosmos, Data, Entity Framework, Power Tools,
Technology Suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness,
Shay Rojansky,
Chris Lanson,
Martha Vickers.
.NET Data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Standup.
Hey, here we are again. We've got another .NET Data Community Standup, and this time we are joined by Erik Sink, who does a lot of work in the SQLite world, including the PCL raw drivers that a lot of .NET people use, including anybody who uses EF Core or Price's Microsoft Data SQLite. But today, Erik is actually going to talk to us about synchronizing with an offline database and being able to keep that offline database that uses SQLite up to date with a database that's sitting in a back end somewhere. Before we get to that, let's do a quick state of the best. I don't know. I'm getting sick of it, and I wrote it, so I don't know what that says.
I still enjoy it every single time we start.
Okay,
Okay,
let's do State of the Unicorn. Okay, so honestly, the team is working really hard in the background. Like Andrew's working on value objects. There's a draft PR out for that, and Shai's been doing all kinds of new stuff in query. With Maurice working on JSON types. Bryce is doing Visual Studio stuff. But there's not a whole lot actually to show right now. So State of the Unicorn is just going to be, EF Core 8 Preview 5 is out. Go get it. It has one feature that we already talked about here a few weeks ago when it was merged, so I'm not going to go into it in detail, but we now use the types, the column name, and we sample data from your database when determining what types to use when reverse engineering a SQLite database. This is something that Bryce did recently, and it's been in the daily builds for a while now, but it's out in EF Core 8 Preview 5. So get that, give it a try, plus all the other good stuff. Check out the What's New documentation, primitive collections, various things around JSON, all kinds of good stuff in there. Shay?
Maybe I'll just say a few words on some of the work I've been doing that's more for Preview 6. So that's ongoing. For those of you who have been following the primitive collections work that went into Preview 4, so there's lots of improvements in that going for Preview 6. So this is a big feature, and it takes several previews to mature completely. The entire team is working on various aspects of it, let's say. But two things that you can already anticipate. So first of all, there's better SQL Server support for those JSON collections, and mainly in terms of performance. But what's even more important, and that's not even a primitive collections thing, is in general, when you do contains, like the link operator contains, the translation for this have been changed considerably, and especially they are much more efficient than they used to be. So the SQL we now generate when you use contains is quite different. We've shifted from an exists subquery to an in subquery, for example, and when you're using a subquery, which means it's no longer a correlated subquery for those of you who like, SQL perf and all that kind of stuff. We've seen magnitudes of orders of magnitude, of performance improvements in some scenarios around this. So in general, lots of goodness around, primitive collections, contains, not just around primitive collections. And a lot of that is you can also do contains over things that you couldn't do before at all. So there's a lot of stuff going on there in query, but that's going to be for Preview 6. So I'm just frustrating all of you.
Lots of good stuff for Preview 6.
Exactly.
Okay, so let's talk about offline sync. Erik.
Very good. Well, thank you for inviting me here on the show. This is always lots of fun, and what it's worth, I like the intro too.
Okay.
Very good.
Thank you. Appreciate that.
I think it's cool. So yeah, I mean, by way of background, I thought, might just introduce a little bit about, what we're talking about here, and it is basically what I think of as an alternate way to deal with data access mostly on mobile devices. The idea being that you can write your mobile app, which in such a way that every time you need a piece of data, or every time you need to modify a piece of data, you just call to the server every time. And this is the easier way to write mobile apps, and most mobile apps are written that way. But it doesn't work well in all cases, and for that reason, we developed some time ago an interest in a model that we informally call rep and sync, which is replication and sync. And honestly, it grew out of our company's history in working in version control, because for the longest time we did version control the way it was done prior to, say, 2008, which is a live network connection all the time. And that's the way most apps are written in terms of data. But when distributed version control like Git got popular, we started thinking about, what if, in addition to doing this for code, we did it for data? And so the rep and sync model that we talk about is very similar to that concept. What if Git was for databases? What if instead of always talking to the database live, you had the ability to have a local clone and synchronize changes when it's convenient for you or when the network is available?
Makes sense.
Makes sense so far?
Yeah, it makes a lot of sense.
So we ended up with a commercial product for this that I can demo in a minute or so. But one thing I'll say, as also by way of background, is that it turns out there are so many ways to approach this problem, and it all depends on how rich your data model is and how much you want the sync component to do for you. And so anytime I demo our product, I don't want to try and give the impression that this is the solution to all sync problems for everyone, because the use cases are so very
absolutely
but because it depends a great deal on things like if all you want to do is synchronize a certain set of rows, sometimes you can get by with something as simple as what I call a high watermark, which is a row number or a date. Just tell the server, hey, I have row 7. Give me anything more recent than that. And for so many cases, this is going to work fine. The challenges of sync get trickier the closer you get to what Git does, which is maybe I need conflict resolution.
Resolving conflicts is always the problem, right?
It's always a problem. It's also, what if somebody adds a column to my table on one side or the other? Do I want sync to deal with that for me, or do I not?
Yeah.
Oh, I'm so glad there's a cat. That's awesome.
That's the show, the star of the show. It's a permanent. It's
Well,
She likes SQLite, so she's pricked up her ears here.
Oh, that's great. So, what if I have foreign keys? Do I want the client side to enforce the foreign key for me? All these kinds of issues, each one of them that you want to support, sort of raise the bar of how hard sync can be to do. And sync is a little bit like Microsoft Word. Everyone uses 10% of the features, but broadly speaking, everyone uses a different 10% of the features. So
exactly,
you can't just ship Word with 90% less features, because it'll only, it's just not. So So let's see if there's anything else I was going to say by way of background.
So this is we've run into these similar issues with trying to solve similar problems in the past. So for those of you who have been around for a while, you might remember self-tracking entities. So self-tracking entities was a thing that we created 15 years ago now for the original entity framework. And the idea was that you had an entity type essentially that had everything in it that would be needed to basically track itself, so know when it was changed, so it could respond to its own events and keep a record of when it was changed and what relationships were changed. And so you do that offline essentially, and then when you came back, you'd sync it up to the EF context and say, okay, tell me everything that's changed, and we'll keep the EF context in sync. Now, obviously, nobody in the world, I hope, is using self-tracking entities, so this wasn't like a major success, right? And I think part of the problem is it's easy to do the easy things there. It's really difficult to cover every case, like Erik was saying. It's really difficult to understand every possible change that could be made compared to every other possible change that could be made to somewhere else, which might conflict with it. So like somebody changes the foreign key, somebody else changes the navigation property, you add some things here, you remove some things from there. Understanding all of the differences in a graph of objects, everything that can change, and handling all of those things correctly, very complicated and ends up with non-robust code with a lot of bugs in it. But if you can simplify it to say we're only going to have this kind of change, we're only going to sync it in this kind of way, then you're able to build something that isn't necessarily as difficult. So this is why I think, to Erik's point, you need to find the solution that works for you, and it isn't necessarily the most powerful thing that does everything. It's the one that works for you and does what you need it to do, right?
Yep. It's interesting. Sorry, I'm doing a segue, but I've never thought about it this way. But in fact, EF Core itself has to deal with a form of this problem when it tracks your entities, which you loaded from the database, right? Like we load something into memory. This is not SQLite. It's an in-memory change tracker representation. We also have to deal with this kind of, okay, now things are changed. They're out of sync with regards to the database. And how do we deal? Of course, that's, again, a constrained problem space, and we do certain things. We're not a completely general purpose database to database synchronization. That's a different problem space. But there's an interesting analogy there to be made, maybe.
Yes.
Oh, you're muted.
I see that I am. Synchronization.
What a headache, right?
Yeah. Once you start working in this area, you do start to see it all over the place. I mean, even Git has synchronization between its notion of an index and your working folder, and then another synchronization concept with your remote repo. And Honestly, I'll be honest. So the product that I'm going to show is called Zumero, and when we first started creating Zumero, at one point we thought maybe it would be the solution for everyone, and years later, when
doesn't everybody go through this
Oh, yeah,
like this?
we actually we came so far in our understanding of the breadth of challenges in this that so we are a product company, but we also do a great deal of custom software work, and the place we've reached is that sometimes a customer says they want a mobile app with a rep and sync model, and Zumero isn't the answer, and we write something custom for them, and that's just how it is, because
even though you're the ones developing Zumero. Yeah.
Well, we're the ones developing Zumero, but we're also pretty good at rep and sync issues in general, and so it's like I said, Zumero has found a nice little market niche for people that need the kinds of problems it solves. But rep and sync is just a big area, and a lot of the solutions are going to be custom. That's just how it is.
Yep.
Okay.
So
you want to see a little bit of how this works in action?
Yeah,
Absolutely.
that sounds like a good idea.
Okay. I think my screen is still shared.
Yep. I mean, just let us know when.
All right. I'm over on SQL Server Management Studio.
Oh, I think Shay and I both added at the same time, which removed it. I have two people driving the car.
Yeah.
Okay. So am I?
Yep.
I only have one screen, so I can't.
All good. All good.
So actually, in fact, I will switch over one other place first. Oh, shoot. Okay, I'm going to switch here, but then I'm going to immediately go here. Okay. So that way I'm not doing that
Inception.
infinitely. So like I said, Zumero is the name of this solution. We sell it mostly to companies that specifically need mobile apps that deal with poor network connectivity. So an example of a typical customer for us is we have a group of companies that sell propane. They do propane installations, and propane is mostly used in rural areas, and rural areas are often where connectivity is poor. And so they have a mobile app that all of their drivers have, so that when they get to and fill up somebody's propane tank, they can enter the data, and when their truck gets back in range of a network, everything gets synchronized and they're fine. These kinds of poor connectivity situations are the very cases where you need rep and sync. And so I am not going to walk through how to install Zumero. I did all of this offline so that we can just go straight to an example of how it works. Since I did none of this, I'll just say that I think our team has done a pretty nice job with getting started docs. We've got videos, we've got samples, we've got all kinds of stuff here you can walk through. And in fact, I walked through this morning because I had forgotten how to do some of this stuff.
Yep.
And in fact, I had to call our dev lead and ask for tech support, which raises the question of maybe he should be the one doing the demo instead of me. But the fact is, you're stuck with me. So there's this getting started docs. We also have in the Azure Marketplace, I forgot about this, and he reminded me that I could have skipped some of this and used this solution, which makes it easier to just install something that has it all pre-configured. So there's that as well. But I'm just going to go back here to SQL Server Management Studio, and as I said, I have most everything all configured, so I'm just going to show a really simple example of how this works. I have a database called Sample.
So you're going to use SQLite for your offline database, and this is the SQL Server here. This is your main database that you're I don't know if you call it a main DB or whatever, but this is where you're going to sync from.
Yes, this is the SQL Server database that would typically be hosted in the cloud somewhere. That can be either a SQL Server instance on your own machine or Azure SQL. In this case, it's actually just SQL Express running on my laptop.
Right.
But any of those would work. and then the sync side for our product and for most anyone nowadays using SQL on a mobile device is SQLite. And so what we're doing is we're trying to do a mirror of whatever you have on your SQL Server instance, be it cloud or otherwise, onto your mobile device.
Right, makes sense.
All right. So I have a table in my database called item, and the table is a real simple schema. It's just a pair of IDs and names. I have pre-populated it with 3 rows, and that's all we've got on this side for the moment. And so I'm going to go back over to what we call ZSS Manager, which is
Right.
Zumero for SQL Server is ZSS, and Manager is the GUI app that you use to configure how you want sync to work. And I have already configured sync to say I want to synchronize that table on my database. And there's this notion of a DB file, which is basically, it roughly corresponds to the SQLite file that you're going to synchronize into. But you can think of it as a named collection of things on the other side that you want synced or not.
Mm-hmm.
So like I said, I've configured this already. And so what I'm going to do is jump into what we call the test client. And this is basically a little SQLite environment that you can use to experiment and test your Zumero installation and your SQL Server backend synchronization. You can test all this without having to go ahead and write the whole mobile app.
Makes sense.
So we have, in this environment, I currently have, hopefully, nothing. The table item is not present at all. So in order to get it, I'm going to have to sync. And by doing this, I tell it I want to sync, and it will sync the DB file we call sync sample, which, as I said, is just a name for the things I want synchronized. I've currently configured all the authentication to be open, because failed authentication makes poor demos. And so I run the sync, it's done. When I run this again, I now have the same 3 rows that I had over on the other side.
So is Zumero here? It's running a server on your local machine.
Yes, it is. Normally, that would not be the way you would do it, of course. But I've got everything configured on my laptop.
Right.
For this.
So
demo.
normally that would be running somewhere else in the cloud, or how does it? Where does Zumero normally run?
Zumero, the server, would normally run in the cloud.
Right.
And I should confess here, Zumero is a bit old school. We've been shipping and supporting this solution for, almost 10 years, I dare say.
Uh-huh.
And so Zumero runs under IIS.
I see. Okay. Right.
Which, like I said, it's a bit old school.
Yeah.
It works. If it works, it works. Right?
It works.
Yep.
And well, to be honest, a lot of our customers are a bit old school too.
Sure.
So I'm going to go back to, we've synchronized the table over here. I'm going to go back to SQL Server Management Studio, and I'm going to click over to this query window, and I'm going to add a row.
Mm-hmm.
And then I'm going to go back to my, where did my test client go? I'm going to go back to my test client. Once again, just hit sync and run the query again. And now I have the other row.
Mm-hmm.
So yeah, these things aren't terribly complicated. But it's just, it works. Let's go back and do something a little more complicated. And this is where I really hope I don't end up with a failed demo. I tested this all once.
We're all waiting.
Yes, I know. So I want to add a column to my table.
Okay.
And so I now have a column. If I go back to my query window and execute. Shoot, did I get the column?
So we're basically simulating the SQLite application via that other window, right? Like some mobile app that's basically going to be looking at a local SQLite database that's been synchronized. That's basically what we're doing here, kind of emulating the environment here.
That's right. That's right. I mean, the SQL Server Management Studio stuff is actually talking to real SQL Server, but back over here, we are in this sort of somewhat synthetic environment.
Right.
That is SQLite. It's just a quick way to pretend like you already wrote your app.
Right. Okay.
So I think I have added that table, but when I ran this query, added that column, but when I ran that query, I expected it to show up here, and it did not. So I wonder if I
demo time
screwed something up. I'm going to click here just to see.
Let's look at the tables. Yeah.
Oh, yes.
Yep.
These are the housekeeping tables that Zumero creates behind the scenes to keep track of everything for you.
I see.
Interesting.
All right. So
we didn't add a column for some reason.
Wait. I bet you it's just a simple thing of refresh.
It'd be.
No, it didn't.
All right.
That would explain why it doesn't show in.
Let's see the SQL that's supposed to do it. Alter table, item, add weapon. Looks all right to me.
Doesn't it?
It does. Oop. Must
and
be.
If I run it again, it fails because it's already there.
Interesting.
Yeah. You've got two different.
Do you have two databases here, maybe?
I do. I bet you.
Are we connected to?
We're connected to the wrong one.
Yeah.
There it is.
There you go. There you go.
Okay, let's try that now.
That looks better.
And let's try this.
There we go.
All right. So now
All right. Okay, now we have the column. I guess some level of failure was inevitable. Back over here in the client side, I'm going to hit sync again. And I'm walking through this deliberately, but I know it's going to fail because I skipped a step and I want to show that step. I've done a sync, but the new column is not there. And the reason why is because
of course,
we want it to be chosen explicitly. So ZSS Manager keeps track of, you specify what you want to sync, and ZSS Manager knows the column is there, but you haven't said you want to sync it. And the reason why is because your mobile app might not be ready. If your app isn't going to be able to cope with the column, Zumero says, well, I'm not sending it until you say to explicitly. So I'm going to change this to start syncing, and in fact it gives me this warning about what might go wrong if you do this. Trust me, this warning happens because our customers called tech support more when the warning wasn't there.
Yes.
So now I am syncing this column, and now when
I'll let you finish your
no, I'll just say
I'm always the perf guy here, so of course there's a correctness thing. Like I guess your warning says stuff like if you're doing select star, then adding a column somewhere could screw that up, right? Because suddenly you're getting new columns in and your program isn't. So that's a correctness bug thing. But there's also, do you want to be overfetching, like synchronizing that column all the way when you don't really need it, right? This is also a way of slimming down what you're actually syncing from the server to the client. So that's also cool.
Absolutely. It's it's very important that we support the ability to sync only some columns of a table for exactly the reason you just gave. We also have what we call filtering in the other direction, which you can specify how to choose rows you want synchronized.
Right.
Because very often on any given device, you only need a subset of rows.
Like if you have multiple users and you have some column that says the user ID, then you can say on this device Shay only needs the rows for Shay, so you filter out only those rows, right? I'm guessing that kind of thing. Yeah,
that's exactly what that's for.
Makes sense.
So I did get the column over here as expected. They all show up with nulls. So the column is there. I'm going to go back now to SQL Server, and let's see. The last time I tried to add something, I failed, but this should add a column, a new row that actually uses the column. So hopefully that will work.
Okay.
And I've done that. And if I go back to my query and run it, now I can see that I have one that uses it. And then before I sync, I'm going to go over to Notepad where I have configured a couple of statements that I'm going to run in the SQLite side.
Right, I was wondering about that. So now we're actually going to change the data in the remote without having it being first updated in the server. And we have to sync it the other direction, essentially.
Exactly. And in fact, I'm going to try and sync them both at the same time. So
that's where it starts to get interesting.
It can. I've actually set this up to have no conflicts, hopefully. So I'm inserting one row, which happens to use all three of the columns, including the new one. And then I'm also updating a previous row, basically saying, that first row, the weapon column is null. It really should have something in it. So I have got these two. I'm going to go ahead and execute.
I'm noticing an explicit ID 6, I'm guessing to avoid conflicting with the other row that you inserted on the SQL Server side, right?
Yes, I have been entering all these IDs as manual numbers. So we could have done this using identities on SQLite, on SQL Server, as well as, those get mapped to the right kind of thing on SQLite. But yes, for the moment,
Sure.
I'm being explicit.
But then I'm guessing if you go with identity, then you have this problem of I've added a row on the SQLite side, and I need to now add an explicit ID on the SQL Server side, although it's using identity. So usually, that's not the way that works. You have to push in an explicit ID all of a sudden, right? I mean,
Yes.
all those problems. Yeah.
Yes, and so I'll be honest. I'm not the dev lead on this product anymore, and I forgot how it works. But what I do know is that Zumero contains a stunning amount of code to deal with that very problem.
Right.
Yeah.
Right.
And there are days when I wish we had just punted and said you can't use identity, but customers don't like that. So
absolutely,
of course,
that's
very popular.
Yeah.
So I did not have semicolons. I think that's the problem. All right. So now I have run these two statements, and hopefully back here, I should be able to see that. All right, this is what the table looks like on the SQLite side. I've got the updated row and the new row. And then the other side we already showed. So I'm going to go ahead and do a sync now again. And now on the client side, I have, oh, look, they got reordered. But the fact is they're right. I have the new row that I inserted on the other side, and my updates on this side are still there. And I should be able to go back here and see the same thing. The row, both sides got resolved together, and everything is back as one happy family.
Perfect.
So anyway, that's as far as I've prepared to demo today. Just pretty simple operation of the solution that we've got. And as I said, there's a ton of different ways that this can be used to go further. Sync, it ends up being a very complicated solution sometimes, but it does solve some nice problems when you're dealing with poor network connectivity and offline use and things like that. So,
yep,
absolutely.
So, a few questions that come to mind, and I don't know about your product, so I'm not trying to be difficult if they are difficult, but hopefully they're not. So when you've got multiple tables and you're dealing with relationships between them, is that all done by manipulating the foreign keys? And do you have to? Does there have to be Is there anything special required to make sure that the constraints in the database are met when you're creating a new relationship, and so you've got a dependent and principal, and the principal needs to be there before you can insert the dependent, because otherwise its primary key value isn't there? Or is that just kind of left up to, is that just something you have to do kind of manually?
In most cases, Zumero tries to mirror all the constraints it can on the other side.
Mm-hmm.
So, for example, foreign keys, as I said, get mirrored over. If the SQL Server side had a foreign key,
mm-hmm.
The SQLite side will have the same foreign key.
Right.
And same thing with primary keys. We do handle things like multi-column primary keys, multi-column foreign keys. Mm-hmm. I believe check constraints go over. Unique constraints that are multi-column also get mirrored over. One thing that people find surprising that we don't do is we do not just blindly copy over every index. And the reason why is because the indexes you need on a device are often different than the indexes you need
mm-hmm.
in the cloud.
Very interesting.
So
very, very interesting.
Yeah, in attempts to actually do that, what we found is that it caused more customer confusion than not.
Yeah.
Because in some cases, the index is there to support the filter, but by the time it gets to the client side, the filter is done and you don't need the index anymore.
Right. So like if you have all your your user data, so that could be a huge table, and you want to index it by user ID so that you can get all the rows for a particular user, right? So that among other things, you can sync them quickly to the client. But then once that data is at the client, that doesn't make any sense to put an index on that value, because you're only going to have those rows for one single user anyway, right? So why are you indexing those rows?
Yes.
Right.
Perfect example. Real quick, am I safe to go back? I don't know if my screen is still visible. Am I safe?
I know. You can go. I've hidden it for now, but
okay.
Yeah.
I was going to bring it back so I could see you guys.
Yeah, no, that's fine. Yeah, no. We're good.
Okay, good.
Yeah, so along the lines of talking about the indexes, so really it's we've talked about a lot on indexes, that the index you need depends on how you're actually using that data, right? And so another case that immediately comes to mind here is that indexes are expensive generally when you insert or update data, right? Because you have to rebuild the indexes. So if you've got something on a client which is basically always just doing a lot more of the inserting, updating, and not really doing any of the reporting queries where the indexes are going to be used, because you run those off the server data, that's potentially a great example of where you can have the same data model, but depending on how you use it, you need different indexes to make it be performant. Which is then we shouldn't go too much further down this path, because it gets a long way towards the idea of replicating your data for other reasons, so that you can write queries against it, accessing it from a certain database store, which might be not even a relational database, for example, but then when you're doing updates to it, you're doing it through a different place, and then you sync them, which brings sync in again, right? Sync's always there. So it's even if you don't have mobile things here, there's a good reason for wanting to have these different database techniques, indexes. It's basically kind of a polyglot idea, right? But it all kind of fits together.
Yeah, there are, it's another great example you just gave, and one thing about it is that that's a little unintuitive is that so a unique constraint is basically an index that's with a different rule around it.
Yeah.
But unique constraints need to be mirrored on the other side, otherwise you have a data integrity problem. You can't.
Yeah.
You don't want the client inserting things that would break the rules when sync happens later.
Yeah.
Right?
That's another problem with that can happen with sync, right?
Absolutely. So
because
as much as possible, you want that sync to always succeed. If the insert succeeded, the sync should succeed.
Although,
where,
and here I'm just trying to be annoying, following the logic from before. If you know that you're only syncing data to the client, that's that's not going to necessitate that unique constraint, or your application doesn't necessarily allow you to insert. Let's say let's say your application is read only. Completely read only, so you can't actually change it. In that case, you don't really care about unique constraints at the client side anymore, right? Because you're not even going to be modifying it. Just So even there, I've never thought about this. Like this is not the first time we've discussed sync like in this team, and we've even had like already a sync community stand up like a year ago or whatever. But this is actually the first time I'm encountering this idea that you have the same database, you're mirroring it, but the constraints and the indexes might be totally different, like Arthur said, because you're using it in a very different way. Your workload is very different, so different things make sense. It's very interesting.
Yeah. It's a can of worms.
Well, and talking about the whole can of worms thing, if we go back to the syncing, and you said, oh well, we don't want conflicts, we don't want constraints to be violated when you sync, right? But this is a great example of where you've got a unique constraint. You've got two clients. One person puts something in there, and the value is unique on that side. Another person puts something in there, the value is unique on that person's client, but the value are the same. At that point, something is going to fail when you sync. So then I guess the question is then, Erik, is like, what advice do you give people to deal with that kind of situation?
So yeah,
don't do it. Don't get yourself in that kind of situation.
Very often in these discussions, yes, that is the exact answer I give. And often when I give that answer, I quote Karate Kid 2 or 3. When
I know those movies very well. Be careful.
Well, when the old guy says, meet me at midnight, my nephew and I will meet you at midnight, and I'm going to kill you. Mr. Miyagi says, you and your nephew lose sleep, I not be there. And the point is that sometimes the best way to not lose a fight is to not be there, be in it.
Yeah, absolutely.
And so we have that is the first answer. Try not to have conflicts.
And I think this connects with what you were saying, and Arthur as well before. Like, this is the general problem of syncing everything is unsolvable, right? So you want to reduce the complexity. You want to introduce some constraints, so to speak, no pun intended. You want to like reduce your problem by excluding certain very complex things which are very hard to solve. Basically, some approaches are, no, I should be able, I should have a solution that supports everything, and I should be able to do everything I want, but that's not necessarily the right way to think about these things.
Absolutely, yeah.
Now, I can say that there have been some other things we learned along the way about sync conflicts that I find interesting. One of them is that Zumero has a bunch of features about how you can define how conflicts will get resolved. In advance.
Yeah, that was my next question, by the way. Yeah.
And I'm not going to demo those because I'm generally uncooperative, and I don't want to demo them. But interestingly enough, one of the things that we learned by providing those features is just how few customers use them.
Interesting.
It's really surprising. When people talk about synchronizing data along the lines that we're talking about, conflicts are one of the first places everyone's mind goes. And yet they're just not as common as people think. And the common cases are pretty easily resolved.
Yes. So this is highly related to concurrency, optimistic or concurrency control in general, even outside of an offline sync, and because we have some similar experience with that, although I don't have hard numbers on it, so you guys can both argue with me over my impression of this. But optimistic concurrency, where you have a concurrency token in the database, and so somebody else updates a row, and then you try and send an update, it will check whether your concurrency token is the one that's in the database, and if it isn't, then you say, sorry, somebody else has already done that. You need to resolve that. Okay, this is obviously a thing that certain people's minds go to immediately, the people who think about these things. Other people, of course, will just ignore
our
it,
minds,
right?
Yeah.
But maybe the people who ignore it actually are onto something, right? Because if you look at any of the documentation about optimistic concurrency, and I'm not talking about entity framework here or .NET instrument, but just how you resolve, there's basically essentially three strategies for resolving a situation where you have that concurrency, right? The first is you say, okay, well, whoever made the last change wins. Like, last one wins, we're just going to save that, right? So the last one wins strategy. We'll come back to that in a minute. The second one is, oh, well, we're just going to fail the new change. We're going to write it to a log somewhere, and we're just going to say that was an error. It happened because somebody else had already updated the record. And that one is, you can argue about whether that's the right thing to do or not, but from a pragmatic perspective, we see people doing that because it doesn't require any interactive flow, right? And so and it doesn't require us saying, oh, I'm just going to overwrite something that's already there, which we may have policies against. It just says log this as an error and leave it to somebody else to deal with. Smart idea. And then the third one is, you give the customer some way to see what the current data is and what the new data is, and come up with a merged example of what the final data should be, and put that in. I've never seen anybody implement that. I've never seen anybody implement that third solution in real life. I've seen people do demos of it. I've written my own demos where I've done it. I've never seen anybody who's actually shown me. So if anybody's watching this and they've written an application where they popped up a screen and had the person in the data has like shown some things and said, have you done this, Shay? You're putting your hand up.
No, I have an idea. I have another analogy. But
okay,
well,
let me finish.
Yeah.
Okay, so if we go back to the three options, one of the things you might notice is neither of the first two actually require you to do any real concurrency handling. The first one, last one wins, doesn't even require a concurrency token, right? If all you're going to do is just write whatever's last, right? It might, because you might, like in the second one, want to actually log that this happened. And so in that case, all you're doing with optimistic with the concurrency token is basically saying this is an error case that somebody else needs to go look at. So you're not resolving anyway. And the number of people, the thing that, to go back to the very beginning of what I was saying, if anybody can remember that far back, there's this group of people who don't ever think about it. They write their web apps, and this is a very large chunk of people in my experience who write their web apps, put them out there, don't ever think about concurrency. But by not thinking about it, they just go with the first option, which is last one wins, which even people who think about it often end up going with that as being the one thing. So maybe the answer to life, the universe, and everything is stop worrying about concurrency and save the last thing that was given to you. Okay. Sorry, move on.
All right, you were next.
Yeah.
No, I mean, if you have any comments, go ahead, Erik.
Well, I mean, how much time do you have? So yeah, there are those three options, but let me just add another one or two.
Okay, yeah.
So one of a subset of the third option, which is give them a way to resolve it, is to provide them pre-canned ways to resolve it. And some of those actually end up useful. So if you go back to the Git model, say we have a file with 1,000 lines, and Arthur modifies line 800 and Shay modifies lines 200, Git will resolve them on this general idea that those two changes probably don't conflict.
Yeah.
It's not always safe. You can actually get yourself messed up there if
Absolutely.
if Shay changed the name of a variable and Arthur was using that variable, it's going to cause a compilation error.
Yeah.
The same thing applies in data, and Zumero has an option to do this. You can say, if your column has 16 columns, if your table has 16 columns, and two people modify two different columns, you can specify whether you want them both to just be accepted and merged together.
Right.
And for an interesting, I'll say, for a significant class of cases, it works.
Yeah.
One person modified the address and another person modified the sister's name. Those are probably not going to conflict.
Yeah.
So Zumero will just resolve that. And by handling some of these common cases, you end up with the uncommon cases just are really rare.
Yes.
Yeah.
Now, in the case of a product like Zumero, what we have found is that the answer is to just stop trying to solve problems, because people use Zumero only if they want to not think about sync. And and you end up with this long tail where if we tried to solve the next set of problems, there would be tons of them. They're all custom. So, if you have a sync problem Zumero doesn't solve, we can find a solution for you, but it's going to be custom. Typically people just, people who don't use a canned sync solution just solve all their own custom problems, or they go back and prevent them.
Yeah.
So
Exactly. So yeah, it's interesting to compare, continuing Arthur's thought. So the general database thing, moving away from offline sync, is again the concurrency token, which protects, so to speak, the entire row, right? So by definition, if anything in that row changed, then then you can't change that anything else in that row. So we don't allow, like by default, we don't allow that different column merge strategy, which you just discussed. And in fact, we can't really do that effectively, at least as a product like EF Core, unless we started loading and comparing and doing stuff that you can do being an offline sync solution, and we can do much less being an ORM. But anyway, it's a very interesting thing to compare. But I also wanted to take this back to your very original metaphor, which I find very interesting. I've never thought about it that way. Git. In Git, talking about conflict resolution, there's so everybody knows the most horrible thing in the world is conflict resolution in Git, right? Like I work on some code, Arthur works on some code, we have to resolve conflicts. You have to have those UIs now, and you have to do a three-way merge. It's absolutely the most awful thing you can do in software engineering, right? So the way to prevent that is usually to coordinate as humans and not work on the same file at the same time, right? It's like, I'm going to work on this now, and Arthur, no, you're going to go work on that, because we want to avoid those conflicts in advance, which is again what we're trying to say here in general, even with with an offline database sync kind of solution, right? I keep coming back to this idea that everybody has their user data or some view of the data that's specific to them. In that case, if the view that I have in my offline sync is my private data in some sense, in any sense, then you've kind of removed conflicts by definition, right? Because you're working on your private set of data, which you've locked, so to speak, by syncing it over to by using your device, right? So that's like a natural way to do things, which basically has already solved the problem in advance for you.
indeed.
So building on that a little bit, I think one of the questions that I actually had was when do you sync? How do you trigger syncs? And and going back to the Git analogy, maybe we can learn something here, because it will be interesting, because one of the tenets of working on a team in software is you sync frequently, right? You sync often. You don't let yourself get out of sync. Like if you're using Git and other people are working also, like rebase often. Why? Because if you've got conflicts, the quicker you resolve them, and the smaller the pieces are that you have to resolve in that conflict, the easier everything comes out to be. And indeed, you may not even have conflicts if you do it frequently enough, where you would have done if you'd done it later, because everything's been kept in sync underneath, and so so do it sync frequently and small. So how does that apply, Erik, in the offline scenario? When do people? Because obviously there isn't somebody sitting there and pushing a button, right, saying sync, right? So
maybe yes, I don't know.
Maybe
We leave that up to the app. It's an app policy decision, and so first of all, I'll just say we have our reasons for leaving it up to the app, because we realized early on that if we made that decision for them, it wouldn't be the right for all use cases. But I also say there is a subset of our customers and users that really wish we had just not left it up to them. They dislike having the choice, So that ends up being another support issue that we deal with, which is how to walk people through. You honestly, the short answer is most people just sync in the background on an interval.
Yeah.
The interval depends a great deal on their particular context, environment.
Yeah.
You know, the propane trucks don't sync every 30 seconds.
Yeah.
Some customers sync as often as, a minute, every minute, just to make sure that they're current. It kind of depends on the volume of changes and the likelihood of conflicts, because the rule you just mentioned really does apply. If you're going to diverge, which is what sync is, rep and sync, it's just like Git. If you're going to diverge, you reduce your pain later if you keep synchronizing as often as you can.
Yeah. I remember a long time ago, I worked on a system for monitoring truck drivers and basically truck tripping. So basically for the truck companies would send out their drivers with various routes that they had to drive and deliveries and stuff, and the software that I was working on was stuff that would run on a device in the truck and would track the driving hours, stop time, where they were, GPS and things like that. And this was back in late 1990s, early 2000s. And we had back nowadays you would just say, right, mobile app with a mobile carrier, cheap enough, right? But back in the day, it was all of these different technologies that you could use to do that communication, like a very low bandwidth satellite connectivity that I can't even remember the name of it anymore now, but you could only send. Well, there was Iridium. It wasn't Iridium. Iridium was the
Sorry.
That would. But it was like you could send like a few bytes, literally, like a few bytes per minute or something up to this thing. So you didn't want to send all of your stuff over that connection. You wanted to only send like emergency stuff. But one of the most interesting ones that we started working on was what has now become Wi-Fi, right? We didn't even call it Wi-Fi at that point. The Wi-Fi standard didn't exist, right? It wasn't 802.11 whatever. It was, we used to call it spreadable spectrum, because basically, it was because the whole idea was based on spectrum hopping, right? That's one of the things that's built into that. But the idea was, this is amazingly cheaper than using any kind of satellite or mobile network, because you stick a Wi-Fi thing on your truck, you stick a Wi-Fi thing in the office, it's offline most of the time. When it drives in, it connects to the Wi-Fi, what we would call a hotspot these days, right? That triggers everything off. It syncs everything up and down, and then the truck drives off again, and it's like, it's just fun to think back to those, it's the same kind of problems, but now we just live in this environment where we're so used to everything being connected that we don't think about it as much. But it still exists when that truck drives, across Montana or whatever, and is out of connectivity for a long ride. It's the same problem that we were dealing with back then. So quite interesting.
It's a great example. I'll confess that I have had my days when I thought rep and sync is the way all apps should be done. Jump up on my high horse and because I think it's fair to say there could be some benefits from rep and sync for any app. This notion that, just like, Git commits are really fast because they're local, and the same thing. But the fact is, the expense and hassle and complexity of sync, even if you get it from somebody else as a component, is so high that typically you only do it when you need it. You're just actually not going to go down the path of everything should be rep and sync.
Yeah, absolutely. Yeah. I think there's one of the things that the cloud becoming so popular has emphasized for me is the continuous nature, the spectrum, if you like, of connected versus not connected, right? And I think there has to be, and in reality there is, but there has to be a lot of pragmatism around that spectrum of connected to not connected as to what you do. And how you deal with it, and whether or not you spend time up front building this into the system, or you treat it as a failure. So since we're on a database thing, let me take database connectivity, for example, right? So when they started running Azure SQL Server in the cloud as Azure SQL, it was a lot less reliable than if you were just running it in your next room in your data center, right? I mean, there was a lot more chance for you to get connectivity issues, and so this resulted in things like an EF having retry strategies, ways that you can recover from broken connection or all of these things down. All of that stuff, everything that could happen there could still also happen in a local data center scenario, right? There's nothing that says, nothing really changed between those two things, except that when you went to the cloud, it became much more likely. Whereas if it was just running in your own data center, it was so unlikely that the connectivity between the database and the web server would go down without it being because the building are burnt down or whatever, and everything's off, that you just didn't design for it, right? That was catastrophic failure. The system's down, so you didn't design for it. When it moved to the cloud, now people starting to design for it, and I think that's the understanding that this is a continuum, and it's okay to not design for it in the cloud too, depending on how important it is for your thing to stay up and be continuous or whatever. But it's like this, you add more complexity when you design. There's not a no overhead cost to say we're going to run this thing distributed, and I think that's what applies to a lot of the kind of cloud native stuff now as well. It's like, yeah, microservices are great. They solve certain problems. Running things in the cloud solves certain problems, but it adds a whole bunch of complexity that you don't think about when you're not doing those things, and you need to take that into consideration. So, like, to your point, Erik, about everything should be ref and sync, maybe. But like you say, there's so much. Do you do it if you don't need it? Don't do it if you don't need it, and you probably don't need it for a lot of stuff, because anything you do adds complexity and makes it more difficult to keep this thing working, right?
Indeed. So, I mean, I don't know how we're almost out of time, but
we're fine.
One thing just to add, it's a little bit of a tangent, and I didn't know if Bryce was going to be on this call. But I prepared to say this in case he was, and I'll say it anyway. So if Bryce were here, I expect him to notice that Zumero we can sync most any change to the schema of a table or the definition of a table. We add a column, delete a column, change something to not null, change a column type. Most of that stuff can get resynced. And I would have expected Bryce to notice that and realize that SQLite can't do any of those operations. And
yes, so you're doing a lot of table rebuilds.
We're doing all these table rebuilds, and I almost expected Bryce to look at me with an accusing stare and say, "You implemented all that and didn't share it with us?" And so I was just going to apologize and make excuses. But, it is an interesting challenge with SQLite for this rep and sync scenario.
Yeah, I hadn't thought of that. It's a very good point. Yeah.
When if you're going to try and migrate those kinds of column changes, you end up with a problem. And
but I mean, even I'm thinking about it. Even stuff like SQLite has no datetime types, and various other types that SQL Server does have, right? So you need to be able to also do data conversions correctly, or in a way that will show the same data on the other side, on the SQLite side, and back again, because that datetime, let's say, is now changed on the client, and now you need to sync it back to SQL Server. You need to convert it the other way, which is really not trivial at all.
We do have built-in conversions for a bunch of those, and sometimes they surprise users. The one that always gets them is GUIDs. We synchronize GUIDs, on the as a binary blob. And we have arguments all the time about whether that's the correct answer. And
we've had those.
Because we'll get people saying, well, it's not stored that way on SQL Server. And I'll be like, well, actually it is.
You just don't see it.
You just don't know that. But no, that's not the way GUIDs are. They're string with dashes. Well, They
No,
can
not
be that
really.
way, but
Not
that's
really.
mostly an
Exactly.
illusion that has made you more comfortable.
That's just formatting. Yeah.
Exactly.
Yeah. And then, but then with SQLite, you also have okay, let's say you go with string with dashes. Is that uppercase characters or lowercase characters? Because I actually had a customer thing on GitHub a couple of weeks ago where the problem that they were running into is that they had GUIDs, but they were in their database as strings, and some of them had uppercase characters in the GUIDs, and some of them had lowercase. And at least on SQLite, those two things are different.
Yep.
On SQL Server, they're the same. So sometimes, it gets this case sensitivity thing. Like everything would be working on SQL Server. On SQLite, the GUIs don't match because they're case sensitive. So
Customers don't like being told, if I gave you what you think you want, you would end up less happy.
Yeah.
Even when it's right.
Yes.
It's just
we have
Right.
that. We have that so much, by the way. Like these conversations with users where they say, "I want X," and we try to tell them, "You don't actually want X. You want Y." Like we infer, but
Like
that conversation is difficult.
In a triage meeting, it will often go, okay, so we've gone through this issue. This is what they're trying to do. Right now, other than don't do that, what can we tell them to help them?
Yeah.
Okay, so let's talk about one more thing since we're here, and if anybody is still watching, amazing. But somebody said GUIDs, and we were talking about syncing. Obviously, we're talking about syncing. We're talking about. But I was curious about GUIDs because this is something that we've talked on the team a few times recently, and it does relate in some sense to having the ability to know key values before the data gets to the database. Right. So bear with me here. I might know what I'm talking about or not.
Yes, I do.
So back in the days when we were doing the old stack, one of the things that we got from customers, EF customers, was I want to be able to use a GUID for a key value because I can know that if the identity of that entity, that thing, as soon as it's created, and I don't have to wait for it to get saved to the database, get assigned like an identity column ID value, for example, in order to know what its ID is. And it seems to me, Erik, that in Sync, this is one of the things you could help you in. Like in the case you said, I picked a number 5 or 6 or whatever for the ID, so it would fit between these two things. But if you're using GUIDs, you can both assign your GUIDs. You've got your actual IDs, and then when you insert them into the database, nothing actually has to change on the client. Is that something that you find people using? Or do they typically not use GUIDs for keys and do other things? Or is it?
It comes up. The issue comes up all the time, and we steer people towards GUIDs as often as we can for cases like you just described where it makes sense. It's eventually somebody will realize that if you're going to start creating unique values without a central source of uniqueness, you need something like a GUID. And they all come back to, maybe we should just have a central source of uniqueness. But eventually the answer is usually GUIDs. The problem is, there again, this is the difference between custom sync and designing for it up front and a product like Zumero, where most of our customers come to us, they've already made all their mistakes. They have an existing database. They just want to synchronize it, and it was never designed for sync, and so it doesn't have these notions. And so, I mean, it's not ideal, but trying to solve that problem for them is a whole lot easier than trying to tell them, "Hey, go fix your entire database first, and then come back."
Absolutely,
that doesn't help them. So, but absolutely, a GUID is the right answer for the cases you just described, and when we have the opportunity, we tell people that. And
do people then? So I guess one of the downsides of using a client-generated GUID is that it's difficult to create effective indexes on that on the database. Is that something that is a concern or a real-world problem for people?
Shay, go ahead.
Yeah, I mean, just to give context, SQL Server has this thing called sequential GUIDs. It's well known in SQL Server, at least. If you just generate random GUIDs and you index over them, which is what you do with primary keys in general, then that's not going to be good because your values are all over the place. They're random, and your indexes are going to be very, very bad. So there's a whole thing in SQL Server. I'm saying this for the crowd, right? Obviously, Erik is aware of all this. There's a thing in SQL Server where you're going to generate GUIDs sequentially. Like they're going to basically monotonically increase all the time based on the time or whatever, and still manage to maximize the randomness so that they don't conflict if things insert at the same time. And then, we've had this on and off discussion in the team whether EF should be attempting to generate GUIDs on the client, like EF itself on the .NET side, versus let SQL Server generate its GUIDs, which I'm not sure. I mean, it's a little bit similar in the offline sync case. If somebody, using Zumero now inserts something into the SQLite database, you obviously have to generate a GUID, like on the client side. You have no other choice, right? There's absolutely no choice, and then you have to sync it to the server. So that's it. I mean, which leads me, I guess, to the question behind it for Erik, which is, I'm guessing you also have to deal with the sequential GUID problem for indexing and all that kind of stuff. Am I right?
That's true, but okay. So what I usually want to do when somebody says what you just said, which I do not disagree with, is put it in context. When you said an index is very, very bad.
Yeah.
The question is, well, in what cases is it very, very bad? Do you actually have the problem Shay just described, or do you?
Sure.
Do you not?
Fair enough.
And there's an awful lot of people who don't actually have that problem.
Absolutely.
Even though they're using client-generated GUIDs, but the fact that their primary key index is not efficient is not really an issue.
Yeah. Simply put, I mean, sometimes the table just isn't big enough for it to make it big.
Exactly.
Make a difference.
Yeah.
So all these things we discuss on perf, there should always be that star, that asterisk next to it that says, this is very important if you're very high scale all the time, massively concurrent and a huge amount of data, but not necessarily if you're not right on that table. So that's very true.
But the problem is those asterisks are just like retractions in the press. Nobody actually reads them. So
yeah.
Well, the problem is to take this particular case, right? That there is clearly an advantage to using client-side GUIDs in certain scenarios, right? We've just been talking about them. That's the sync scenario where you're generating the GUIDs client-side because there isn't a central source of identity, as Erik said. And there are clearly cases where it makes sense to have server-generated GUIDs because the amount of data and the queries that you're doing on that table need there to be sequential values in the primary key column. So now we're, as designers of the platforms or the frameworks, the libraries, as opposed to the applications, we need to make a choice between which one of those advantages do we choose by default. Do we choose the thing that is potentially higher performance in this case, but is not client side, and so won't have, so we'll have these other issues when people try and use it that way? Or do we choose the thing that has the advantage client side, or do we try and do we stop, as you said earlier, Erik, not make a decision on how often to sync because it's something that they need to take? And as that's the question that we're frequently asking, right? Is what's the good default, or when is it there is no good default and we're just gonna not do it, not provide any answer? And I think that's the challenge that we're thinking about with the GUIs now, but coupled with the fact that we have an existing behavior, and if we change it, it's a breaking change. And so that, always adds a whole lot of weight to the let's keep doing what we're doing right now, because breaking changes are painful.
Well, and, in different contexts, the solution, the appropriate solution varies a lot. I mean, if you for some subset of the situations that we've encountered, we actually find identity columns work better because if memory serves, the way Zumero handles identity columns is you get an ID on the client and it might change on the sync.
Yeah.
Okay.
Yeah.
So and we
you like remap it basically as part of
Yeah.
the sync.
Exactly.
Yeah.
And
that,
so
that makes a lot of sense. Yeah.
keep that all transparent, but so and occasionally we have to tell somebody, it's like, hey, you got ID 37, but that's not don't store that anywhere else.
Yeah.
Yeah.
If you stored it in another table, we'll find it, but don't put it in a temp file or something.
Yes.
Because
Yeah.
it's subject to change until the sync
Yeah.
happens.
That is quite a risk
And
if somebody is not aware, obviously. Yeah.
That's the thing, like, because we could do a similar thing with GUIDs, right? So we could generate client ones immediately, but treat them as temporary, and then use sequential GUIDs on the server. But then there's a subtle breaking change that we'd be making there, which is the GUID that you got before you inserted is not the same key as the same
Indeed.
value as you got back afterwards, and it's nervous to me as a manager to make that kind of breaking change.
Yeah, it makes sense. We don't do that, but we could have. That's an interesting idea.
I'll say my thought about this. So, I mean, first, obviously, this thing that we're discussing, that Arthur is discussing for a potential change in EF is something that we would, obviously also provide an opt-out of, obviously, so to go back to the previous behavior, but that's still a breaking change if we change it by default, right? So people who do not read the breaking change note, suddenly you have a bug. But like more generally to the like more philosophical question, Arthur, that you asked, do we do we prefer the high performance thing out of the box,
Yes.
or do we do the other thing, which helps in certain scenarios as well? And I'm not saying it doesn't. I mean, it does absolutely help. My answer, that my personal preference, the thing with performance is that it's not discoverable, as opposed to a behavioral thing or a bug, or if something doesn't work for your scenario, you will know it very, very quickly, because you're, again, I'm not talking about the breaking change aspect of it, just in general, like making these kinds of decisions. If the thing bombs, like you get an exception, that's perfect. You know very early in the development process that thing is not going to work. And therefore, I will always prefer a bombing, an exception, to something being slower 100% of the time, because nobody can, unless you go in and start benchmarking and understanding. And that's so few people, it's a bit like the conflict resolution thing, by the way, where everybody thinks about conflict resolution right away, but it actually happens so little. In the same way, perf, everybody thinks about perf, but the number of actual people measuring their perf correctly and reliably and arriving at the right answers is very, very, very small. We get perf issues all the time on the repo, and most of the time those are kind of missing the point or benchmarking incorrectly, or perf is very, very hard, which is why I always prefer the product to just work efficiently out of the box and maybe not support certain scenarios, rather than support all scenarios but be slow. That's kind of like a very philosophical thing. Anyway.
Sounds like wisdom to me, though.
I said my piece.
Well, we could talk about this for ages.
Absolutely.
The way you say it makes perfect sense. But of course, the question is, where is that line for it works outside of the box, out of the box, right? That's the critical thing. It's like if we ship something that for 95% of the people will throw the first time they use it, then that's not good. That's a non-starter, right? So it's always finding this trade-off between the perf thing is important enough to make this thing not work, and if it throws an exception and tells you it's not working for this place, better, it always throws it early when you first start your app is even better. But basically, if you know you've done this one thing and it has a perf implication and you can do this other thing, that's great. So very often it's not like that, right? If we make this breaking change for the GUID things, it's not clear that there's going to be like we can put a warning in the log saying we've made this change, but we don't know that it's actually going to impact you. And it would be worse for us to start throwing an exception all the time for all of these apps that are currently working would break. And to go back to the other side of this, all those people not doing perf, but to Erik's point about do they actually have that problem with the index? Do
and
they
I
actually
agree.
have a problem? Do
I
they
agree.
really
This
need
is
to be
this is
testing
very
this? Or, yeah,
this is very
so
case by case, and it should be handled
it's
very
fairly
pragmatically.
philosophically.
And
Yeah,
I completely agree. I mean, I said my philosophical piece, but then every case where you actually have to make that decision, you have to be very
right.
connected to the ground and pragmatic. And
So we're not going to change
absolutely
the
agree.
default GUI generation
Oh no,
strategy.
I haven't
Are you
necessarily
agreeing
giving
with
up.
that then? Yeah. Okay.
Nope.
No.
Well, up a
Not going to
level.
be that easy.
If we pop up one level of abstraction, I would just say this. I mean, I've reached the age where people ask me what I've learned by running a company all these years. I'm old, and one of the things I always say is that you really can't solve problems. You can trade some problems for ones you might like better.
Yeah.
You
That's true.
can't.
Yeah.
I mean, and most of
Yeah.
the skill of solving all these of dealing with all these issues is understanding what problems you
Yes.
have and what problems you will like better and when you won't. It's just
Yeah.
it's
Yeah.
all
Yeah.
about these trade-offs. So.
Absolutely, and there's the grass is greener thing shows up all the time.
Oh,
Like
yeah.
there's so many things where back in the day whatever you've been working on, you thought we can do it this way or we can do it that way, and you had a big discussion or not, and you decide let's go do it this way. And now 3 years down the road or however long, you're going to look at this and you're going to say, man, I wish we'd done it that way. Look at all of these problems we had doing it this way. But what you don't realize necessarily is had you done the opposite, you would now be looking back and man, look at all these problems we had doing it this way. We really should have done it that way back 3 years ago, but you don't. But it's the grass looks greener. Because you only understand enough about how problematic a solution is by actually doing it, right? And so the solutions that you don't implement suddenly sound a whole lot better because they don't have any of these problems that you never found.
Yeah.
So true.
There's one more aspect to this. First of all, I find like what Erik said is 100% true and very wise. Like you trade problems for other sets of problems. One interesting distinction, like between, let's say Arthur and I and my standpoint, where we're working on a product like EF, and then Erik, who is working on Zumero, but also on the custom integration. I'm getting the sense that in general, when you do a Zumero installation or deployment or whatever, you're very much in there working with your customer. It's not like I'm not sure, I might be wrong, but it's not like a thing that somebody downloads off the internet and then it deploys themselves. It's more of a, is that accurate?
It varies. Very often we're quite involved, and then there are cases where
it's literally off the shelf.
Yeah. So
okay.
I mean, they usually can't get all the way through deployment without help from us,
some
fashion. But people have varying degrees of involvement with us.
So yeah, you have these two opposite extremes, right? Where Arthur and I, we work on a thing where we're there on GitHub, but that's about the extent of it, right? We have to make decisions on the product as a product. There's not going to be, we can't, customize it for him, customize it for her. It doesn't work that way. It's just one single product, and we have to do our best to, make these super universal decisions. I mean, EF Core has more than 1 million monthly users, right, Arthur? I don't even know how many.
I'm not allowed to talk about that.
Oh, I'm sorry. It has like a massive amount of users.
Cut the cable.
You misheard me. What I said was massive. They both, massive. So
yeah,
anyway,
that's right. Yeah.
Massive amounts of users, right? And we have to make these like this thing that we just mentioned. Like, does the GUID get generated on the client or on the server? We have to make a decision here that's going to affect everybody, absolutely everybody. Whereas the opposite end of the spectrum is where you are. Maybe you do have a product, but that is maybe also a bit of a building blocks that you can put together in order to support the customer's need, and there's a lot of integration there. That's a very, very different kind of thing where you're going to be reasoning for that specific customer. These are very, very different worlds, basically, and it's fascinating how how that works.
Oh yeah, for whatever value of massive applies, our quantity is lower, and we have that actually gives us more flexibility and fewer risks sometimes.
Absolutely.
Because in general, we probably want the same things, which is less unhappy customers.
Yeah, absolutely. Yeah, it's the same goal. Exactly.
The more customers you have, the more chances you're going to make somebody unhappy.
Exactly.
Yep.
Yeah, that's the story of our lives when you work on something like .NET or EF. Absolutely.
Yeah.
Absolutely.
Okay, well, it's been a really interesting discussion. We kind of veered off the main topic there, but it was very useful. So
As always.
I've
appreciate
enjoyed
you.
this talk.
Appreciate very much you coming on, Eric,
Yep,
and
was
appreciate
a lot of
everything you
fun.
do for the .NET community. Very
Yeah,
highly
everybody,
valued.
for everybody who hasn't understood this, everything happening with basically everything happening with SQLite and .NET, it relies on this person right there in front of you. So if you're using EF Core or Microsoft Data SQL Client or anything on SQLite basically in .NET, then this is the guy who makes it happen like every day.
Yeah.
So really,
Thank you, Eric.
thank you very much.
Okay.
I appreciate that.
Thanks everybody else. I'll just show this one message. We're not going to go into this deeply. If you've got a composite primary key of 2 correctly GUIDs, is that very bad? Yes, that's very bad. Go redesign your database immediately.
I'm not sure why you would ever do something like two GUIDs.
Composite of 2 GUIDs makes no sense. So
yeah,
sorry.
I mean, is like a 128 bits not enough? Like one GUID is not enough. That would be interesting. Like that would be like a massive data set.
But you know what you should do? You should test. You should do some good benchmarking with benchmark.net and figure out.
I will just say one thing. So the fact that it's 2, even if let's abstract the fact that it's GUIDs, having 2 properties like 2 columns and you're having a composite key is not necessarily a problem as long as there's going to be an index over that over those 2 columns, and that's going to work well, even if it's a GUID, which again I'm not sure why somebody would do, but it should actually work.
But a single column with GUIDs should be unique, right? So.
Well, to be fair, I mean, these things are only unique across the known universe. If you go to the metaverse, I mean, to be
in the
unique
metaverse,
all
be
reality.
careful of that word. Be careful of that word.
GUID v it's like IPv4, like it was all right for a while, but now we need GUID v20. Oh, somebody put one of those things in there, didn't they?
Yeah, ULID.
Yeah, doesn't work very well.
I mean, we're in 2023 and nobody needs IPv6 as far as I know, right? I mean, the whole world still somehow manages to use IPv4, so I'm just going to put it out there.
For our,
trying to wrap up and you go there.
Yeah.
Well, for our, we have a meeting on the team on Fridays where we just waffle about random stuff. We just talk about random stuff, not work related. And this is a great example of how we haven't run out of oil. We also haven't run out of, back in the 80s, everyone was telling us we were going to run out of oil, which we shouldn't go there in terms of why we haven't or whatever, but we haven't. And we were going to run out of IPv4 network addresses like really, really soon now, like 90s.
I remember
90s. We're not IPv6 isn't going to be ready in time. We're going to run out before it's ready. There's going to be somebody walking around with their phone and they won't be able to make a call because there's literally no IP address to give their phone. And yet somehow it didn't happen.
Yep.
These things, sometimes they don't happen. Okay, anyway, let's end there. Thanks, Eric. Thanks, Shay. Thanks, everybody.
Very much.
Thank you.
We will see you again next time.